Okay, this is Michael Diamond, assessment number 1 on forces, using a LiveScribe notebook and pen to transcribe this problem. The problem states a girl pulls her little brother on a sled across a frozen lake and friction is so small you can ignore it. The sled with the boy has a weight of 400 newtons and the girl pulls with a force of 100 newtons at an angle of 30 degrees above the horizontal. So let's first draw this as a free body diagram to start working the problem. So in this case we have the x-axis going this way and the y-axis going up and down. The body of the sled is in the middle and the forces that we have pulling are basically going to be your newtons, or your normal forces, and then downwards you're going to have your weight, which in this case is equal to the force of gravity and the weight that's stated in the problem of 400 newtons. So combined is 400 newtons. The big sister is pulling with a tension force of 100 newtons at 30 degrees. Now, to calculate the normal forces of the ice on the sled, we must subtract this vertical component of the forces that the girl exerts on the sled and the boy from the weight of the sled and the boy. This calculations can be done like this. Your normal forces equals 100 newtons minus 100 newtons sine of 30 degrees, which equals 400 newtons minus 50 newtons, which then equals 350 newtons. Next we're going to calculate the net force, which is here. So net forces is Fx equals 100 newtons cosine of 30 degrees. So to do that formula, we're going to use this. Equals 100 newtons cosine of 30. And to find the force going into the y direction, we're going to use F of y equals 100 newtons sine of 30 degrees. And that will be done down here as well. A function of y, 100 newtons sine 30 degrees. So when we compute the net forces in the x-axis, 100 newtons times cosine of 30, we get 86 newtons, 86.6 newtons. And then across our y-axis, 100 newtons sine of 30 degrees equals 100. And as stated earlier, we computed our normal forces, so that's actually going to be annotated up here. Now, if we wanted to find the mass of the little boy, we can take our measurements that we have from here, and we can use the formula that mass equals 400 newtons divided by our gravity, which is 9.8 newtons per kilogram. And that equates out to 40.8 kilograms. Last but not least, because of force in this direction, since the child is being pulled in the opposite direction, our force in that direction is equal to 0.